welcome to a video on implementing stacks. And from the last video, we found out that stacks are what are called last in, first out data structures. And the way you implement a stack is very, very simple. I mean, you can implement a stack many ways, but what you want to do is perhaps the simplest way is to use an array. Okay, so here we have an array. Let me show you exactly what's happening here. This is supposed to represent an array the best I can in code here. And here's our indices. And if we want to push something on the stack, what we have is a stack pointer, a top of stack pointer that points to an element that is the top of stack. So we're going to initialize the top of stack to be 0. So basically what you have here is the top of stack is pointing to this element here. And if you want to push the number 313, or actually the number 4, we'll just make it simple, the number 4 on that stack, then we push the number 4 on the stack and then increment the top of stack to be 1. So here, picture the top of stack, this variable here pointing to this location here. This top of stack it actually serves two purposes. It tells you how many numbers are in the stack, as well as the location of where a number should be placed when you push it. So if I want to push the number 5, top of stack points here. I push the number 5 on there. Okay, and the top of stack now is 2. Okay, so what you're going to do is say you want to push the number 3. Push the number 3 there, top of stack is 3, increment the top of stack to there. The top of stack is pointing to this element. It doesn't actually point directly to the top of stack. It points to the element right after it. But if you want to pop something, you're going to decrement the top of stack and take that element and remove it. That's the simplest implementation. Now remember, top of stack takes on two forms, two interpretations. It points to the location of where the next push is going to occur, as well as it tells you how many numbers are in the stack. So what we're going to do here is say, well, now that we basically have an idea of how to implement the stack, what we're going to do is define a stack. There's our say we have no parameters. You know, you have to define, with a basic array, you have to define how big that array is, and we call that the capacity. The capacity is basically how many numbers can be stored in this data structure. And right now, I pick whatever the JDK uses for their capacity. They use 16, a power of 2. Now, this is something relatively new. Here's what we have here. This is called, when you have this as a method, like we have here, we're calling it as a method with parentheses. This is telling the compiler to go locate another constructor that takes one parameter here. And so 16 is an integer. We come down here. What we're going to do is call this constructor, and that constructor takes the 16. We're going to define this class's data to be an array of 16 elements. Okay, so if your application requires, if you know your application requires, say, 100 elements in the stack, then you don't call this in your main program. You would say stack of 1, pass it 100, and it goes directly. It creates your array. And by default, fields end up being zeroed out. But I think what I'm going to do is to explicitly say this dot top of stack equals 0. And that top of stack variable right now being 0 means there's nothing in that stack. Now, if you want to push something on the stack, this is kind of, let me just erase this right now for now. What I'm going to do is I'm going to say, remember, I want to push a number on this stack. Okay, so what I'm going to do is take that value and stuff it into the array data of top of stack. Make sure you now increment top of stack to be 1 more. Okay, and likewise, what I'm going to do for pop is something, I took some liberties here. I'm going to show you exactly what I'm talking about here with these minus and plus pluses. But when you're let me literally say pop. Pop, I want to remove something from the stack. So what I'm going to do is take my data. Okay, actually what I'm going to do is top of stack minus minus, decrement the top of stack. Okay, and then what we're going to do is return the item that is there on that location. Okay, so remember, top of stack doesn't actually point to the element that is the true top of stack. It points to one just above it. So if you want to pop it, you need to decrement the stack and then return that value. Now you can see right off the bat there's going to be some issues here. Okay, the problem is this. The problem here is there's only so many pushes you can perform. Once you do 16 pushes with no pops, you can't go and say data of 16 because there is no data of 16. There's going to be an error there. Okay, so we're going to throw an error because you're trying to push an element into a full stack, and then likewise with the pop. I mean, if top of stack is 0, okay, meaning there's nothing in the stack, decrementing top of stack is asking you to return data of -1, and that doesn't exist. So we're going to fix this in the next version. So we're going to assume that everything is working well with our basic pushes. Now you notice I changed the original code from a one-liner to 2 lines, and basically you could combine these 2 statements. Okay, let me combine those 2 statements. Let me comment this out and comment this out, and simply say this: data of top of stack plus plus equals value. Spelled right, of course. Value, and that's exactly the same thing as what we've got hidden over here. Okay, comment it out. See, remember, people don't make use of this a lot, and I want you to make use of this. This is something that happens in all languages. Okay, top of stack plus plus returns the value of the stack before you increment it. So before you increment it, I store the value in data of TOS, and then as a side bonus, you increment the top of stack. This is exactly what you're doing here. Now this pop, let me go ahead and comment this out and go back to the original code I had. See, with one line I can do exactly what line 30 and 31 does. What I want to do is return the top of stack, but I need to decrement the top of stack. Alright, so this is, I put the minus before because we have to return, we need to decrement the top of stack first, return that value, and then use that as an index to data, inside the data. So these 2 guys are exactly the same. Okay. All right, let's continue what we have. We did the basic pushes, the basic pops. Now pops is going to return whatever, this is a stack of integers, so it's going to return an integer. Pushes don't return anything, that's why that's a void. Peeking is just that. You're not going to pop the thing. What you're going to do is look at, simply inspect what's on the top of stack. So TOS -1 doesn't change TOS. It just basically says, give me the top of stack -1. That's a side calculation. Look at what's inside data. But meanwhile, top of stack doesn't change. Then we have other couple of methods. Empty. If the stack is empty, how do we determine that? Well, we determine that by simply looking at top of stack and seeing if it's 0. I mean, these are one-liners. And how many elements are in the stack? Just return TOS there. And then I performed a little toString that we might want to print out the state of the stack. And basically what you can see here is I'm going through all the elements in the stack up to TOS, concatenating that value to its return value, and then returning the string that results from printing all this out. So let's take a look at the driver. And I'm going to look at stack 0. That was the thing we just talked about, stack 0. Okay, and stack 0. Now, why is there an error here? Cannot be resolved the stacks. There's no stack 0. Oh, excuse me, stack 1. There is no stack 0, of course. Eclipse is smart. There's stack 1. That's the thing we just talked about. Let's run it. We do 3 pushes. We should see 3 things on the stack. We pop something. So the last push is the thing that we pop off. We should see 22. And then if we print the stack again, the last 2 elements should be there. Let's see if that's the case. And it is. It does work. All right. So what we're going to do here is stop the video. I'll let you give you time to digest what we just talked about. And what we're going to do is fix up the problems. We're going to prevent the popping of an empty stack. We're going to prevent the pushing of a full stack. And we're just going to embellish it. But this is the basic code that you should be aware of to deal with stacks. All right, we'll see you in the next video.